Leshire Math here. Let's consider question number 6. Question number 6, Roman 1, part A. Sketch a graph of the curve with the equation y is equals to 1 over 5 power x plus 3, where x is an element of real numbers. Show on your sketch the coordinates of any point at which the curve crosses the axis, the equation of the asymptote. Part B, you are given using logarithm and making your method clear, solve the equation 1 over 5 power x plus 3 is equals to 23, giving the answer to 3 significant figures. Roman 2, given that log of x to base 4 is a, find in its simplest form in terms of a, log of 64x to base 4, b, log of 2 over x squared to base 4. So question number 6 majorly test on logarithms and exponential functions, and we'll start with the first section, that is Roman 1 part A, where we are required to sketch the curve. When it comes to curve sketching, especially for exponential functions, we'll consider 3 major aspects. One, the nature of the curve, and B, we'll also consider the point at which the curve cuts the vertical axis, that is the y-axis, and number 3, we'll also consider the equation of asymptote. Now, based on what we have in this case, normally if we are given a function y equals to ax, and in this case a is greater than 0 but less than 1, we know the nature of the curve. So let's see how to sketch this. So Roman 1 part A, I want you to recall that at any given point when you are given a function, let's say a function y equals to a, capital A, small letter a, x minus h, then plus k. In this case, y equals to k gives you the asymptote. It gives the horizontal asymptote. So based on what we are given, we're given y equals to 1 over 5 power x plus 3. So it means y is equals to 3 is simply the horizontal asymptote. And number 2, we also need to determine the point at which the curve cuts the y-axis. So we know that at y-axis x equals to 0. So therefore when we substitute x here, what we are going to have is this. We'll have when we substitute the value of x with 0, then it means we'll have y equals to 1 over 5 power 0 plus 3, and this means we'll have y equals to 1 plus 3 and y is equals to 4. So it means the point at which the curve cuts the vertical axis is 0.04, and already we know the equation of the asymptote. So when it comes to sketching, it becomes quite easy. let's delve into sketching. We'll draw our horizontal axis. Or we'll draw our axis. This one is the horizontal axis, and this is the vertical axis. And of course, number 2, we can sketch our asymptote. Asymptote in this case is at the point y equals to, or it's simply y equals to 4. So we'll have this one becomes your asymptote, y equals to 4. Then we are also supposed to, now we are supposed to sketch the curve. Already we've identified where that curve is going to pass through along the vertical axis. The curve is passing through the point 0,4. We can indicate here the curve will pass through the point 0,4. And also we know the nature of the curve. So this is what we are supposed to have. As the sketch of our curve. We can consider Roman 2 or part B of Roman 1. Part B, Roman 1 says that using logarithms and making your methods clear, solve the equation 1 over 5 power x plus 3 equals to 23 and give the answer to 3 significant figures. So solving part B, we are given 1 over 5 power x plus 3 equals to 23. First, we can simplify by taking this 3 the other side of the equal sign. So this one means we'll have 1 over 5 power x equals to 23 minus 3, which is 20. And therefore, we'll have 1 over 5 power x equals to 20. But 1 over 5 power x can also be written as, we can also write this one as 5 power negative x using the laws of exponents, especially the negative index law. This one should be equals to 20. What are we supposed to do here? We can introduce logs on both ends so that we'll have log of 5 power negative x equals to log of 20. And if you can recall, we know that if at all we have log of a, recall that if you have log of a power b, this one can also be written as b log of a. So that is what we'll have here. So this one is the same as, negative x log 5 equals to log of 20. You can divide through by log 5. You can also divide through by log 5. And having our calculator, we'll have log of 20 divided by log of 5. And this gives you 1.86. So we'll have negative x is simply equals to 1.86, and therefore x will be equals to negative 1.86, of course, when you divide both sides by negative 1. So this becomes the solution to part B. Now we can also consider Roman 2, for Roman 2, going back to the question, you've been told that given that log of x to base 4 equals to a, find in its simplest form in terms of a log of 64x to base 4. So you've been given, from the question, we've been given that log of a rather, we've been given log of x to base 4, log over x to base 4 equals to a, and therefore you are required to determine log of 64x to base 4. Now we can recall something here using the laws of logarithm. If recall or remember, if you are given log of a plus log of b, this one can be written as log of ab. Of course, the bases are the same. In this case, both of them we have base 4. So if we translate this back to what we are dealing with, then it means 64 is just the same as 64x is the same as 64 times x. So this one we can write as log over 64 to base 4 plus log of x to base 4. But on the same note, the number 64 can be written as 4 raised to power 3. So if we break 64, 64 is just the same as 64 is the same as 4 raised to power 3. So when we substitute that, we'll have log of 4 power 3 to base 4 plus log of x to base 4 is already a, so plus a. Here, taking this 3 as the coefficient of the log, we'll have 3 log of 4 to base 4 plus a. And still recall that the log of a number the same to its base is just equals to 1. So it means that log of 4 to base 4, this means that log of 4 to base 4 is simply 1. So therefore, what we'll have here is 3 plus a. So this is part A, Roman 2, part A, and we can also consider Roman 2, part B. Roman 2, part B, you've been given log of 2 over x squared to base 4. So here we'll have log of 2 over x squared to base 4, which we can write this one as a log of 2 to base 4 minus log of x squared to base 4 using the division law of logarithm. Now, the number 2 itself, how do we get the number 2? Remember, 2 is just the same as the square root of 4. And when it comes to powers, we can say that 2 is just the same as 4 raised to power a half. So that means what we'll have here, we can write this one as log of 4 power half to base 4 minus 2 log of x to base 4. Simplifying this further, we'll have a half log of 4 to base 4, of course, minus 2 multiplied by a, and in this case your solution becomes a half minus 2a as the most simplified form. So this one becomes your solution, a half minus 2a, as the solution to part B.